All right, Spartan fans, in this video, we're going to look at 4 different types of solving logarithmic/exponential equations. A few of these you have already done, and a few of them will be new. So let's look at an exponential equation that you have already solved in the past. So that would be something like 4 to the x equals 8. This is an exponential equation. Why? Because the unknown is the exponent. And we've been doing this for a little while. Try to rewrite with a base that's the same. So in this case, this would be a base of 2. So 2 squared is 4, equal to 2 cubed. Equal bases equal exponents. So if x to the m equals x to the n, then m equals n, which is going to be really useful for us in a minute. So 2x is 3, x is 3 halves. You've been doing this before. Okay, so what happens when it's something that we cannot rewrite using the same base? So for example, what happens if it's something such as 6 to the x equals 8? Okay, well, 6 to the x equals 8. Contrary to popular belief, you cannot divide both sides by 2. So I'm going to rewrite this in logarithmic form. It's an exponential form. I'm going to rewrite it in log form. In general, that's how things are going to work. If it's an exponential form, you're going to rewrite it in log form. If it's in log form, you're going to rewrite it in exponential form. The base is going to be 6. The argument is going to be 8. This is exact form. So when I ask you to write the answer in exact form, that's it. If you wanted to find out the decimal approximation, you would plug it into your calculator. Okay, so we've been doing these 2 types of problems before. What happens, though, when I cannot rewrite using the same base? So we're going to go back to log equations temporarily, and we're going to look at those first. Okay, so I'm going to give you something such as the log base 2 of x plus 1 plus the log base 2 of x plus 7, notice my language, equals 3. You must combine into a single logarithm first. So we're going to combine these using the product property. And this is going to become the log base 2 of x plus 1 times x plus 7 equals 3. And now I'm going to change forms. The base is going to be 2. The exponent is 3. And that's going to be equal to x plus 1 times x plus 7. And now hopefully this is an equation that you know how to solve. 2 cubed is 8. I'm going to multiply out, distribute, combine like terms. That's going to be x squared plus 8x plus 7. It's a quadratic. It has to be equal to 0 before you can solve. So this is going to be 0 equals x squared plus 8x minus 1. Okay, so in order to solve this, I'm going to use the quadratic formula. Hopefully I haven't made any mistakes along the way. Make sure you simplify and reduce. There's no exception to the simplifying and reducing rule. 68, I believe, is 4 times 17. I hope that's right. You guys aren't here to correct my mistakes. Yeah, okay, and then reduce. So the answer to this is going to be -4 plus or minus the square root of 17. You need to check. The argument of a log can never be negative. So negative 4 plus root 17 is 0.123 about. And negative 4 minus the square root of 17 is negative 8.123, give or take. Okay, well, negative 8.123 is not a viable answer. When you plug it in and check, you're going to get a negative argument. So the only answer to this problem in exact form, the exact answer would be negative 4 plus root 17, and that would be approximately 0.123. Which answer should you leave? You should give the one that the directions tell you to do. So that is what happens when you have a log equal to a constant. Let's look at what happens when you have a log equal to a log. So when you have a log equal to a log, what I mean by that is something like the log base 5 of 2x plus 3 is equal to the log base 5 of 3. Okay, so this really isn't in log form or exponential form. It's, I don't know, it's just a log equals to a log. All right, so just like if the bases are the same, the exponents are the same, if the log base m, if the log of m is equal to the log of n, then m equals n. Okay, well, if you look at this particular problem, they both have a base of 5. Don't tell me that you're going to cancel out the logs. You don't cancel out logs. You use a property that allows you to say 2x plus 3. These are the nicest ones. They're, in my opinion, of all the kinds that we do, they are hopefully the least difficult. Divide by 2, x is 0. Let's do another one of those. They get a little bit more complex, but not too bad. You need to make sure that if you can, you use properties to combine into a single logarithm. This is not the problem I want to do, sorry. The problem I want to do is the log base 3 of x minus 2 times the log base 3 of 5 is equal to the log base 3 of x plus 1 minus 2 times the log base 3 of 10. Okay, well, the good news is I see a lot of the same bases. These all have a base of 3, so that's helpful. I'm going to use my properties and I'm going to combine the logs. So this is going to be the quotient property, subtract logs, divide arguments. So that's what's going to happen on the left-hand side and also on the right-hand side. But we're also going to do the reverse power property. So this becomes, I'll show an extra step, the log base 3 of x minus the log base 3 of 5 squared, that's not 10, be careful of the careless mistakes, log base 3 of x plus 1 minus the log base 3 of 10 squared. Okay, so now I'm going to skip steps. So subtract logs, divide arguments. So 5 squared is 25, so this is going to become x over 25. Then this is going to become the log base 3 of x plus 1. Subtract logs, divide arguments, 10 squared is 100. So now there's a property that says the bases are the same, the arguments are the same. Cross multiply. And that's going to give you 100x equals 25x plus 25. 75x equals 25. Divide by 75, reduce, you get 1/3. Okay, and you should just do a quick double check. When you plug in x is 1/3, that's a positive argument. 5 is a constant, don't need to worry about it. When you plug in 1/3, 1/3 plus 1 is positive, so it's always good to just do a quick double check of your work. So that is an example of a log equal to a log, or we did a log equal to a number in the problem right here. So let's look at what happens when you have a problem with exponentials and you can't reduce to a same base. Okay, let me just double check to make sure I've covered what I need to cover. So I want to go back to the beginning problem that we did. One of the beginning problems where it was 6 to the x equals 8, and we rewrote it and we left it in exact form. So let's go back to that. Okay, so instead of being 6 to the x equals 8, let's change it to 6 to the x equals 2x minus 1. Well, if I wanted to rewrite it in log form, what's the base? Is it the log base 6 of 8 to the 2x minus 1 equals x? Is it the log base 8 of 6 to the x equals 2x minus 1? It gets kind of harried. So we're not going to do it either of these ways. Just like you can add 2 to both sides, or divide both sides by 6, or square both sides, etc., we have a property that allows us to take the log of both sides. So I am going to actually take the log of both sides. You can do that, you can. So this ends up being the log of 6 to the x equals the log of 8 to the 2x minus 1. The base is 10. The base is not 6 or 8. The base is 10. And what I'm going to do now is use the power property to bring the x in front and the 2x minus 1 in front. So this becomes x times the log of 6 equals, be careful, use parentheses. So what I just did here was I used the power property. Okay, something that's difficult to wrap your brain around might just be that, how am I going to solve this now? The log of 6 is a number in your calculator. The log of 6 is 0.778. The log of 8 is 0.903. This is just a fancy number in your calculator. So to solve this, I'm actually going to distribute on the right-hand side. I'm going to distribute 2x times the log of 8 and negative 1 times the log of 8. And that's going to give me 2x times the log of 8 minus the log of 8. Okay. So the goal when you solve is to have x on one side and the constants on the other. So I'm going to subtract 2x times the log of 8 from both sides. And now what I have done is I've got variables on one side and constants on the other. The goal is to solve for x, so I'm going to factor out an x. So this becomes x times the log of 6 minus 2 times the log of 8. Solve for x, you're going to divide both sides by the log of 6 minus 2 times the log of 8. And we're going to simplify that. Right now, it's pretty messy. So this is going to become x equals negative log of 8 divided by, okay, I'm going to use the reverse power property. So I'm going to bring that 2 up, and it's going to become, let's see, 8 squared, 64. So this becomes the log of 6 minus the log of 64. And you can simplify that. This becomes negative log of 8 over the log of quotient property 6 over 64. I'm just going to rewrite it. I'm out of room. 6 over 64 is, let's see, divide by 2. 3 over 32. Reverse change of base. So this is negative log base 3 over 32 of 8 equals x. That is a really nasty answer, but that is the answer. So let's plug it into our calculator and see how we did. I really hope I did it right. So I'm going to take a minute here to, you can fast forward, type it into my calculator. Log base 3 over 32. I'm sure you can hear me typing in of 8. Okay, this is approximately 0.878. Okay, so I'm going to check my answer. You should as well. And let's hope it's right. So 6 to the 0.878. I've got the actual number in my calculator. Does that equal 8 to the 2 times 0.878 minus 1? And let's see, 6 to that answer. $4.825, give or take. And I did indeed get 4.825. Okay, let's do another one of those. Okay. What happens when it's something like, let's do 2 to the x plus 1 equals 5 to the 1 minus 2x. Your first order of business should always be, can you rewrite it using the same base? And you can't. 2 and 5 cannot be rewritten with the same base. So there's this thing in math instead of the log. So a logarithm has a natural base 10. There's this thing called a natural log. And natural logs are used a lot in finance in the real world. So a natural log is written as ln. And instead of having a base of 10, it has a base of e. And e is called the natural number. And on your calculator, it's the key above the ln. And it's 2.718, blah, 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 blah. And this comes from in finance, when you're calculating compound interest. This is where the natural number comes into play. So when we do some word problems, when I come back to school, we'll talk more about it. But many times you'll see that instead of taking the log of both sides, we'll take the natural log of both sides. And so it's ln. And that's literally what you say, the ln of blah, blah. So the log with a base of e is the same thing as the natural log of x. We don't write e. Okay, so I'm going to use the power property, and this is going to become parentheses x plus 1 times the natural log of 2 is equal to 1 minus 2x times the natural log of 5. I'm going to distribute, and And that gives me x times the natural log of 2 plus the natural log of 2. The natural log of 2, this is literally a number in your calculator. The natural log of 2 is 0.693, blah, blah, blah. And that's going to equal to the natural log of 5 minus 2x times the natural log of 5. We want everything with an x together on one side. So I've got x natural log of 2, negative 2x natural log of 5. I'm going to put those together on the same side by adding 2x times the natural log of 5. And the constants, natural log of 2, natural log of 5, I'm going to put those together. So that's going to become the natural log of 5 minus the natural log of 2. That's not the natural log of 3. It is, however, the natural log of 5 halves. Quotient rule, all the rules apply to natural log that apply to log base 10. And then on the left-hand side, I'm going to factor out an x. That's going to give me the natural log of 2 plus 2 times the natural log of 5. I'm going to divide both sides by the natural log of 2 plus 2 times the natural log of 5. I'm going to do a little bit of simplifying first. Simplify now, simplify later, it doesn't matter. Power property, bring the 2 up, it becomes 25. It doesn't matter when you simplify, now, later, who cares? Product property, add logs, multiply arguments. So this becomes x times the natural log of 50. Every time I make these videos, I think, man, I really hope I didn't make a mistake 6 steps ago. And you guys are all lost. Divide both sides by the natural log of 50. So this becomes the natural log of 5 halves divided by the natural log of 50. That is your answer. No change of base with natural logs. You're not going to change this. This is not the natural log base 50 of 5 halves. No, because a natural log has base e automatically. That would be your answer. So your homework for today is a lot of practicing with different rules of, or not different rules, different equations. Some of them you need to use properties, some of them you do not.